Hello everyone, this is Mirzai from Cal Poly Pomona, and in this lesson we're going to go over moving average method of forecasting. If you remember in the previous lesson when we went over the constant method of forecasting, where every period we looked at the actual of the last period as the forecast for the next period, we had a specific pattern in our data. If I look at the pattern or time series of cells for thousands of gallons per week in a data set gasoline, what I observe is a horizontal pattern. So to do that, if you go under Insert and choose the line chart here, you see the pattern is very horizontal. It means that it's average around some value with some variation around it. So when we see a horizontal pattern, we can using a constant method of forecasting, moving average, or exponential smoothing. Previously, we went over constant method. Today, we're going to talk about the moving average. So let's take this to R to implement moving average forecasting in R. Previously, we said the dataset gasoline is available in your course document, data files, chapter 5, gasoline.xlsx. And we showed that you need to save this dataset as a CSV file and save it in a work directory that your R is working off of. If I get the current work directory or the folder that the work currently reading the files off of is my download. However, if it wasn't this directory where my data is, I should have changed it to the directory that the dataset exists in. I'm going to go ahead and run it and show you that getwd still will be on the download folder. Next, we showed how we can read the file. I have to make sure the file is in this folder. And if I execute this line, I'm reading the CSV file and save it in a variable called gas. If I execute gas, I see my data set. Now I want to make sure that the data set is properly brought to the platform. I either can get the head function if my data set is big, or just highlight and execute gas and see if the data set is properly brought into the platform. The next thing I did in the previous video, I also changed the name of this column to cells because it's a rather long name for the second column. So I'm changing the names and data frame gas in the second column to sales. So if I execute this whole line and look at the data set gas highlighted and executed, I see the second column's name has changed. And these are just the preliminary things that we do at the beginning to read the data and make sure that its headers are in a proper format, in a shorter format for us to start working with the data. Now let's get started with the moving average. So in the moving average, we basically calculate the average of the last K period. So I would say average of last K period. Now that means we have to define K. How many previous period we want to average out to calculate the forecast for the next period? Let's start with some value for K. So if I start with K equal to 3, that means I'm going to look at the last 3 period to make a forecast. So my forecast is not going to start until from period 4 because I have to have some actual values from the last 3 period to be able to make a forecast for the next period. So the first 3 period don't have any prediction. Also, I want to go ahead and create a column prediction, which doesn't have any values at the moment in them. So prediction and the data frame gas. So $ prediction is going to be NAs. If I execute this line and then highlight gas and execute it, you see the predictions are NA. Another thing I want to do before I start with my prediction is that I can make a prediction for period 13, because in period 13 I can calculate the average of period 10, 11, and 12 and make a forecast for period 13. So I'm going to go ahead and add a row in the bottom that is the week is 13. The cells, we don't know what it is because we don't have its actual value yet, but we can make a forecast. So I'm going to go ahead and add a new row in the bottom that is 13 NA and NA for the actual and forecast. And later we can fill up the forecast, however we don't know what the actual value is going to be in the next period. Alright, so let's go ahead and do that. So I'm going to combine this data set gas. Basically you call it, for example, new gas, or I call it N gas, is equal to R-bind. R-bind is when you stack data frames on top of each other or vectors on top of each other. So I put gas and then I make another vector which is a combination of 13, NA, and NA. If I execute this line and then execute in gas, you're able to see that a new row in the bottom has added, which we don't know it's actual, but we can make a prediction for it. And now we said k is equal to 3. We said we average the last 3 period to make a forecast for the next period. So basically, if you have a counter, this counter starts from 4 because that's where you can actually make a prediction. So I can say in the ngas $ prediction is equal to the average of the ngas cells column rows 1 through 3. Don't forget to put 4. So in data frame gas, the prediction of the 4th period is equal to the average of the cells in the last 3 period. If I execute this line and then highlight and execute in gas, you see that 19 has popped up here, which is the average of the last 3 period. Now, if I want to create for the 5th one, it's going to be very easy. So this time, the 5th period is going to be from 2 to 4. So as you see, the counter is going to increase. So now let's go ahead and create a loop. As opposed to copy and paste and changing it, we can create a loop that execute this. What is the maximum that we can hear? It can be 13, right? So basically, we started from 4 to 13. We didn't have anything for the first 3 period. So if I have a counter that starts from 1, it can go all the way to 10. If counter is 1, for example, you're going to have I plus 3. So when I is equal to 1, you're going to have I plus 3 here. And if the counter is 1, this is going to be I. If the counter is 1, this is going to be I plus 2, so that it generates 3 for you. Now, if, for example, I is 2, the next counter, you're adding 3 and you get 5. And when it's 2, you still again have I here, and it's going to be I plus 2. So that, as you see, based on the value of I, you can create some automated numbers here. When I is 1, when you want to make the first prediction is going to happen for period 4, and you're adding week 1 through 3. And when it's 2, then you have for prediction you're making is for month 5, and you're making this average of week 2 to 4. 2 plus 2 is 4, and so forth. However, sometimes it's problematic when you put I plus 2 in this side. I prefer to put that as B equal to I plus 2 here, and put this as I through B. So that way it avoids any problem. So you can say every time you're getting the average from the I up to B, which B is equal to I plus 2. Now, how do I create this loop? You add the for term here, and you say for I in 1 through 10, and then you open a curly bracket, and you end it right here. So the OR loop in R is this format, for, and then you have I in A to B. You define the range of I, you open a curly bracket, you close it, and you put the process in between, whatever you want to do. So in this case, we said for I into 1 through 10, do this job, basically calculate the prediction the same way that is defined here, and then you close the curly bracket. Now I remove this part, but I enter so that you see this curly bracket is open here and closed here. It doesn't make any difference, but makes it cleaner so you know where you open and close parentheses and brackets. If I execute this for loop and then look at ngas data set, highlight and execute it, you see all these predictions are generated. So when you went from I 1 through 10, you went up to 10. The reason was because you had k equal to 3, so instead of going to 13, you went 3 period less. So basically this 10 here, I call it capital B, is equal to 10, which 10 is equal to the number of row in your data set minus the k that you have. K in this case was 3. The big B is going to be 10. So that's the replacement that you put in here, because you're making prediction for 10 period when your k is equal to 3. If your k is, for example, 4, then this is going to go up to 13 minus 4, which is 9, and so forth. So this is going to be dynamically changing based on the value of k that you put here. Also, we said I plus 2 because k was 3, so you added not only the period I plus 2 more period after that to take care of the 3 period that you want to average out. So instead of 2, you can always put k minus 1. That's how many more period you want to add on top of I. So if I have 5 period, you have period I plus 4 more, which counts 5 for the number of period that I want to sum up. So this way your B is updated based on the value of k that you're updating. Also, for the prediction, if you're having k is equal to 3, your first prediction starts in period 4, which is I plus 3. Now, if k is 4, then it starts from the 5th period. If it's 6, then it starts from the 7th period. So instead of k equal to 3, here you can put any other k and make this dependent to the k value that you have defined. Now, if I go ahead and execute this whole process from k equal to 3 one more time, nothing in this case is going to change, but you see there's no errors generated, and you basically recreated the same thing you already had. But the interesting thing is when we change k. Now let's go ahead and execute this line. So everything in the prediction is NA again. So I'm going to go ahead and execute this, and if I look at the gas data set, everything is NA and NGAS. Therefore, if I run it again, everything is NA here. Now I want to change my k to 6, and I want to rerun this line because this line is connected to k. Now it automatically adjusts everything based on k. So I execute this line, and I execute B, and then execute the rest of this code. Look at the NGAS. As you see, it automatically, when k is 6, your prediction starts from 7, and then calculates all the prediction up to period 13. So automatically takes the average of the first 6 period. Now to understand this for loop, let's do an exercise. So let's put one value for I so you understand. So I in this example goes from 1 through V. So if I put I equal to 1, what happens? And you know that k is equal to 6, right? So I execute this 2 line and see what happens. So when I is 1 and k is equal to 6, this value becomes what? I execute B, and I see the B value is 6. What does this mean? It means that when you calculate here, the average of the cells is going to go from period I, which in this case is 1, to 6. And that makes up the prediction of period 7. Why? Because if you execute I plus k, it gives you 7. And if you look at the B is 6. So basically it says the prediction of period 7 is equal to the average of the first 6 period. So as you see, this for loop takes care of the moving average with any k that you put in here. So now let's go ahead and execute this for 8, but before we do that, we have to make sure that we revise our data set to NAs and execute for k equal to 8, and then I'm going to go ahead and run everything else. If I look at the NGAS data set, you see it starts from 9th period. Basically, it's adding up the first 8. All right, now let's say if I want to calculate the errors in this forecasting, I have to calculate the difference between the actual and prediction. So I can go ahead and a new column to NGAS data set called residuals or errors, which is equal to NGAS data set column cells minus NGAS prediction. So basically, the difference between column cells and prediction gives you the residuals. If I execute it and look at the NGAS data set, you see that the residuals are calculated for those that they are not NAs. When you have NAs, automatically these becomes NAs. So you can go ahead and square these residuals, and I put residuals S at the end, meaning that they are squared. So if I execute this line and look at the data set again, you see that this new column residuals S has been created where all these values are squared. So now I can go ahead and sum these values up and calculate the sum square of error, or I can average these numbers up and calculate mean square of residuals or mean square of errors. So in this case, because your k is equal to 8, you have these numbers from 9 through 12. So you can make that also dependent to your k. So I can say the mean square error is equal to the average of your residual squares. The rows here should be defined based on k. So if k is 8, you're starting from 9. I'm going to define it as a variable here. If it's a to b, the lower bound, upper bound here, I'm going to define it as your number of row of data set minus 1. right? Because we always don't have the very last one because we don't know its actual. So B, the upper range, is going to only go to, in this case, for example, your B is going to be 12 because the number of rows in the data set is 13 minus 1 is 12. And if you execute A is going to be 9. So now I have defined A and B. I have to implement it here so that we are only looking at the mean of the residuals that are squared from A through B. If I execute this line and look at the MSE, you see that is 9.59. Now if I want to look at the mean absolute value of the residuals, I can go ahead and revise this line, mean absolute error. This time, instead of looking at the residuals that are square, we're looking at the residuals. However, on the average of the absolute value of the residuals. So we need another parenthesis here for the average. So the absolute of the residuals from A to B, and you're looking at the average of them. So if I execute this line, and you see that we get 2.7, you can also calculate the mean absolute percentage error. In that case, you divide this absolute value by their actual, and they're looking at the average of these percentage. So I'm going to go ahead and copy the same line with the difference that here, these residuals are divided by the same range of their actuals. So instead of residuals, I have to put sales because sales is the actual value. So we look at the residuals divided by sales or actual. We look at the absolute value of them, and then we average them out. So if I execute this line and look at this mean absolute percentage error, it's going to be 0.14. So these are the three methods by which we can determine how much error a forecasting has: mean absolute error, mean square error, or mean absolute percentage error. These three metric tells you how good of a forecasting method we have. You can compare these MSE and MAE and MAPE with the constant method and figure out whether a constant method is better or a moving average is a better method. Also, you can change the value of K on the top and try to see these values for different values of K. For example, you can run this code again for K equal to 6. However, make sure that you initialize the prediction value with NAs and you add that final row 13 to your data set, and go ahead and run everything else. As you're running this, make sure that the line for the residuals also is in there because we're running the whole code. So I added this line, making sure that the column residual is in there again. And this time I can take a look at my MSE, MAE, and MAPE and compare it with the previous value that we had for the K equal to 8. As you see, MSE in the previous case was 9.5 and now is down to 6.7. Also, if you look at MAE, it has gone from 2.7 to 2.25 and from 0.14 to 0.12. Seems like in all fronts, the value of error has decreased from K equal to 8 to K equal to 6. You can keep doing this practice by changing the value of K. However, instead of that, we can create a for loop and save all the values of MSE, MAE, and MAPE for different values of K in a data frame. So I'm going to remove the K here. So to create the for loop on the top, I'm going to say for K and 2 to 12. 2 is the minimum value of K and 12 is the maximum. If we put K equal to 1, basically we're looking at the constant method of forecasting. And we cannot go to 13 because we don't have 13 actual value to use to average up to make prediction. We only have 12 known values. And then I open the curly bracket and close it down here. If we run this for loop, we will not have any memory of MSE, MAE, and MAPE except the very last run. So I'm going to go ahead and execute this. And if I execute MSE, MAE, and MAPE, they will be all NAs. So if I look at the data set NGAS, you see that the only thing that we have for the last period is the prediction, which has come from the K12, which is the average of the last 12 period. So you cannot really calculate any error term. Why? Because you don't have the actual. You cannot calculate the difference between the actual and prediction and calculate residuals. So therefore, what you see here is only for 12 and you don't have memory of what had happened in the past. To avoid that and have the memory of the MSE MAE, and MAP for all the Ks, I create a vector called matrix and initialize it with null. Then inside my loop, I'm going to add matrix, which is equal to the row bind of metric from the previous run with the new run. I'm going to say rbind matrix in each run plus the new vector here, which includes K. You want to include MSE, MAE, and MAPE. So in each run, we row bind, which means we stack the previous matrix on top of the new matrix. So in the first run, when K is equal to 2, this is null. What we get, null on top of this vector of matrix that we calculated. So basically, we only get this vector. In the next run, we add the vector of the previous run with the new one that we calculated, and this loop allows us to stack up rows in different runs of the for loop. Eventually, you're going to have stacked up values from k equal to 2 to 12. So I'm going to go ahead and run the for loop, and don't forget to run the matrix vector initialized. And now look at the matrix here. Now what you see is all the value of MSE, MAE, and MAPE that are calculated for different values of K. What we want to see is that what K gives you the minimum MSE. As you see, the minimum in this column is associated with K equal to 6. If I use MAE as my metric for the accuracy of the forecasting and look at this column, the minimum seems to appear around here, which is again K equal to 6. And if I look at the MAP, also the minimum happens around K equal to 6. What you can do also is to create plots for each of these and look at the minimum point in each plot using a visual observation and investigation. So now the final point here is that which K do we use for forecasting? The K that gives you the minimum error. And what type of error are you calculating? Are you looking at MSE, MAE, or MAPE? It's up to the analyst to choose one of these metric as the criteria for minimizing the error of their forecasting. Most commonly, we use MSE. Now, if I look at my MSE, I would choose K equal to 6. That gives me the minimum error. However, you are open to choose MAE or MAP as the criteria for minimization of the error in your model. In both cases, accidentally in this scenario, you also get the same K to have the minimum error. However, it is possible that you get minimum error from a different K for MAE and MAPE. So this is not always the case that the same K gives you minimum across all different metrics. With this, our lesson is concluded. Thank you for watching, and please refer to your Blackboard for your assignments. Thank you.